Let's read this problem. Mrs. Sanders has 3 grandchildren who call her regularly. One calls her every 3 days, one calls her every 4 days, and one calls her every 5 days. All 3 called her on December 31st, 2016. On how many days during the next year did she not receive a phone call from any of her grandchildren? Good. So a very helpful hint here is that it tells us that all 3 called her on the last day of previous year. That's a very good sign because it aligned the starting point for us, and things can get a little bit more complicated if it does not. Let's consider that afterwards. Let's solve this problem first. So she has 3 grandchildren. So basically 1 every 3 days, and 1 every 4, and 1 every 5 days. We can see that this is really about, depending on which way you call it, either call that divisible or call that multiple, right? Let's call that a multiple. For example, for the 3s, we need all multiple of 3 days, every 3 days, and then the 6th day, the 9th day, and so on and so forth, right? And same thing for every 4 days and every 5 days. Good. And of course, sometimes they may call her all at once. For example, the last day on the previous year, December 31st, 2016, all 3 called her. So she must feel really good on that day, huh? In any year, there are 365 days. So we want to pick all the multiples of 3s, or 4s, or 5s, or both, or maybe all 3. In that case, a Venn diagram will certainly help. Let's call this circle all multiples of 3s, right? Let's just call that 3. And then let's call this circle all multiples of 4s. And of course, that circle all multiples of 5. So there are certainly intersections. Let's find how many days are there that at least 1 grandchildren call her. Okay? So within 365 days, so how many of them are multiples of 3s? That's fairly straightforward. So it's 365 divided by 3. So that'll be 121. And we have a remainder of 2. But that doesn't matter. We have so many days. 121. Similarly, we have 365 divided by 4. So that's 91, and has a remainder. So that's 91 days. 365 divided by 5, that's 73. And yes, so there are 73 multiples of 5. But there's certainly something double counted. For example, some days are both multiples of 3 and the multiple of 5. Or multiple of 3 and a multiple of 4. Let's find them out. So let's find all the days that the first 2 grandchildren call her. The first 2 are every 3 days, every 3 days and every 4 days, right? So then that'll be every 12 days, 3 times 4. These 2 children will call her on the same day. So that equals to 365 divided by 12. That equals to 30 with a remainder of 5. Okay, so how do we call that? Let's call that n, right? 3 and 4. And that equals to 30. And similarly, 4 and 5 equals to 365 divided by 4 times 5, on which 2nd and 3rd grandchildren call her on the same day. So that's 365 divided by 20. That equal to, let's do the calculation. 365 divided by 20, so that's 120, 165, that's 8, 160, okay, with a remainder. So that's 18. Right? That's 18. Good. So then let's calculate the last pair. So the n, 5, and 3. That equals to 365 divided by 5 times 3 equals to 365 divided by 15. Let's see, 365, 15. We put 2 here, 2 times 15, that's 30. And 65, that'll be 4, will be 60 with a remainder. So that's 24. So this is 24, and I put 24 here. All right? So those days are double counted because 2 children call her on the same day. All right, so are we done? I guess not. Look at this area, the very center one. That's the intersection of all 3 sets, which means all 3 children can call her on the same day, which happened in the history, right? That happened on the last day in last year. When that happens, we call that all 3, 3 and 4 and 5. So all 3 grandchildren can call her on the same day. So that equals to what? That's 365 divided by 3 times 4 times 5, right? So basically every 3 times 4 times 5 days, all 3 grandchildren will call her on the same day. And that equals to 365 divided by, so that's 12 times 5, that's 60. All right, so that equals to 6 with a remainder of 5. All these has remainders. This one equal to 6. Good, so we know the number of days, either 3, the first grandchildren call her, or the 4th, that'll be the second grandchildren call her, or 5, the last grandchildren call her. Any of them call her would equal to the sum of all these. So that'll be 121 plus 91 plus 73. And we need to deduct the days that at least 2 grandchildren call her, because these days are double counted. So that'll be minus all these 3 numbers, right? So that'll be 30 plus 18 plus 24. All right? And we need to add back the days that all 3 grandchildren call her, because they were triple counted, right? So they were triple counted here, counted once, once, and once, 3 times. But that they were deducted too many times. They were deducted once, and once. So basically all 3 times were deducted. You see? But we still need them. We still need the sweet days that all 3 grandchildren call her, right? We need to add it back. So that'll be 6. We add back the 6. All right, let's clean some space. Okay, let's do the final calculation. So this one equals to, how do we calculate that? The 1's digit will be 1, 1, and 3. So that's 5. The 10th digit is 2, 9, and 7. So 2 plus 7 is 9. So that's a double 9. That's 18. And we carry a 1. So 1 plus 1, that's 2. 285 minus the sum of these 3 numbers. That's 48. That's 68, that's 72, right? And plus 6. Let's do the subtraction. So that's 2, 1, 3 plus 6. So that equals to 219. So these days are the number of days that at least 1 grandchildren call her. So how many days are there in a year? That's 365 days. So the final answer will be 365 minus 219. That equals to what? So let's say 365 minus 215. Minus 4 again. So that's 150 and minus 4. So that equals to 146. So where is it? Here. D. That's our choice. All right. That's so much for this problem. It looks a little bit messy, but it's not as hard as you may think. Because in the beginning, we say that this piece of information is very helpful because it aligned a good starting point. So we can simply consider the multiples of 3, 4, and 5. And if you know this Venn diagram, then the rest of the work will be a lot easier. Okay, so what if we make this problem a little bit harder? Or what if we put similar problems in the higher level exams? For example, AMC8. So let's clean up some space and take a look. All right, let's clean up the space. Right? So basically, there are many ways to modify this problem. So I will just show one of it as a good starting point. I may leave some homework for you to do after this video. All right. So let's modify this problem. And this didn't happen. All right. So let's say we know the second and the third grandchildren called her on the last day of 2016. Let's call that C4, meaning the grandchildren who call her every 4 days, and C5. So they called her. We still keep them aligned. Called her on the last day. They called on December 31st, 2016. And unfortunately for us, that the first child, let's call that C3. C3 called her the day before. So let's say C3 called her on December 30th. Let's say, okay, December 30th, 2016. So this is our new problem. They are no longer aligned. So then what now? How do we do this? So when we calculate the number of the days that each grandchild call her will be easier, right? It doesn't matter we align them or not align them. But what matters is how do we calculate the days two grandchildren call her at once? So when they are aligned, we can just find the common multiplier, right? But in here, they are not aligned. So a good way to handle this is that we force them aligned. So let's move the days forward a little bit so that we can get them aligned before we do the regular calculation. So let's continue. What I mean is that children 4 and 5, they will still do the regular thing, right? Every 4 days and every 5 days. So we know that every 20 days, these two grandchildren will call her on the same day. So we call that every 20 days, right? And 40 and 60. And how about the first grandchild? The first grandchild call her every 3 days, but it's not aligned. So we need to first plus 2 days, right? And then this grandchild will call her once. I'll use one circle here. And afterwards, this grandchild will call every 3 days regularly, right? So what we should do is then it'll be plus 5, right? Plus 8, and so on and so forth. And how can we align them on these days, right? And then afterwards, we will do the regular calculation as the original problem. What I mean is here, right? So this is like we need to find the days that has a remainder of 2 when divided by 3, right? So let's try that. So let's try each of these, right? So for 20, let's say minus 2 here, minus 2 here, minus 2 here. Let's see which one of them is a multiple of 3, right? we need to adjust this or offset these 2 days. Then let's see, what do we get? We get 18 here. Actually, we don't need to do the rest of the calculation. This is 38, right? It doesn't matter because the first one is already a multiple of 3. Good, which means since this day on, all 3 grandchildren will get aligned. Then we know that from the 20th day, so that will be 365 minus 20. So for the rest of the year, that will equal to 345. For these many days, we'll just do the same calculation as the original problem. We have to do the first 20 days separately. All right, so let's look at C4 and C5, these 2 grandchildren. Okay, how many days that we don't have any visits? So since this is a 20, so we can just count them. If it's a 40 or 60, we probably need some calculation, right? So let's do the C4. C4 will be on the 4th day, the 8th, the 12th, the 16th, and the 20th. C5, that will be the 5th day, 10th, 15th, 20th, right? This day is double counted. And how about C3, who call her every 3 days? So remember, we are starting from 2, right? So, okay, so 2, 5, 8, 11, 14, 17, 20. Good. Let's see how many days we have at least 1 grandchildren call her. We have 4, that's 1, 2, 3, 4, and 5, right? Because this is double counted, we cross it out. And that's 5, 6, 7, 8, 9. This is double counted. That's here. We cross it out. This is double counted. We cross it out. 11. That's not. So we need this. How about 14? We need it. 17. We need it. And this is triple counted. All right. Because this number 20 is small enough, so we can use this methodology. Or if it's some number around 40 or 60, probably we need some calculation or the help of Venn diagram. Fortunately for this modification, let's just do the hard way. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. We have 12 days with at least 1 children call her. So the number of days that nobody call her would be 20 minus 12. That equals to 8. So we need to bear this number in mind and then do the rest of the calculation with the regular Venn diagram and the multiples of numbers. What if none of them are aligned on the last few days in the last year, 2016? So that could be a nice homework for you to practice. If you like this video, please subscribe and thumb up. If you have questions, please comment.